Hello, my name is Laura Modali and welcome to Science for Education, supporting teaching and learning in science education. In this video, we are going to discuss about magnets and magnetic force. And I'm going to use a magnet exploration kit by STEM Powered Kids and some items I gathered around the house. Do you remember playing with refrigerator magnets? Plastic figures, clippers, pictures, or letters that can be arranged as you want on the refrigerator door? Since we were very young, like 4 years old, we have accepted the fact that those items stick to the refrigerator because of the magnets attached to them. In other words, we are familiar with magnetic force. Today, let's talk more about magnets and magnetic force. If you gather up a few magnets from around your house or office, you can establish basic facts about their behavior with simple experiments. Magnets attract metallic items made of iron or steel. Magnets do not attract items that are made of silver, copper, aluminum, and most non-metallic materials. The three common magnetic elements are the metals iron, cobalt, and nickel. A magnet has two ends called poles, the North Pole and the South Pole. The two poles are named from the North Magnetic Pole and the South Magnetic Pole, or more properly, north-seeking and south-seeking poles. When two magnets are brought closer together, they will attract or repel, depending on which poles are brought together. Like poles will repel one another, for example, north and north or south and south. Meanwhile, opposite poles will attract, for example, north and south. Next, the area around the magnet where the force is acting on another magnet or magnetic materials is called the magnetic field. It can be observed by using a compass placed at different points around a bar magnet. Also, you can use iron filings to visualize the magnetic field around a bar magnet. Here, you can conclude that magnetic forces of the magnet are strongest at the poles, because the lines in these areas are closest together. Let's look at this experiment. Here I have a plastic hexagonal rod with two magnets at the end and a base plate with 4 ring magnets attached. I'm going to hold the hexagonal rod above the base plate, and then I will release the rod gently. The rod floats, and this is not magic, but magnetism. What happens here is, like poles repel each other. The poles are on the faces of these magnets, but they can also repel each other when arranged edge to edge. The force of repulsion keeps the hexagonal rod floating above the base plate, even when it's spinning. Now there are two types of magnets based on the source: a permanent magnet and an induced magnet. A permanent magnet is one with its own magnetic field. The magnetism cannot be turned on or off. For example, a bar magnet. Meanwhile, an induced magnet is a material which becomes magnetic only when placed within a magnetic field. Induced magnets only attract other materials and lose most or all of their magnetism when removed from a magnetic field. Let's take a look at this experiment of anti-gravity sculpture. Here, I have a base plate with a support arm and 4 ring magnets attached at the end of the arm, a string, and several nuts made of steel. One nut is tied to the string, and I'm going to attract the nut to the magnet while the string is attached to the base, so there will be a space between the nut and the magnet. Now, one by one, I'm going to add more nuts to the first one until it looks like a sculpture. What happens here is that the first nut became an induced magnet because it was placed within the magnetic field, and it is now attracting the other nuts too. And when it is removed from the magnetic field, it loses its magnetism. There is a lot more that I could say about magnets, but we'll save that for another video. Thank you for watching this video. I hope you guys enjoy watching and learning about magnets. Remember, it's not magic, it's magnetism. See you next time.